to explain Sommerfeld relativistic model. Why it is introduced and why it is called as relativistic model. One of the drawbacks, fine structure of spectral line, we have already studied in the previous session. To clarify that fine structure, Sommerfeld had introduced his relativistic model basically. Why it is called relativistic model? This will be explained in the next slide. His concept is one more quantum number L is required to describe suborbit. Sommerfeld atomic model. First of all, we will go to the postulates of his atomic model. The path of an electron around the nucleus in general is an ellipse with a nucleus at one of its foci. What does it mean? The electron revolves. This is the electron. This revolves around the nucleus in an elliptical orbit. What may be the position of nucleus? It is at one of its foci. Second postulate is velocity of an electron moving in an elliptical orbit varies at different parts of the orbit with relativistic variation in the mass of the moving electron. As the distance between these two, nucleus and electron, it is varying with the position of electron, right? So at different parts of the orbit, the distance between these two is different. So velocity may also be different. And also it is a relativistic particle. So mass variation must also be included. One more postulate is to describe the position of electron in orbit, you need two physical quantities. One is r and one is phi. What is r and what is phi? The distance between nucleus and electron is r, and the phi is angle made by position vector of electron with the major axis, right? Sommerfeld atomic model. There are two variables. Two variables are required to describe the position. I have already told. Those are r and phi. Because of these two variables, the electron had radial velocity as well as transverse velocity. Because of radial velocity, it gains radial momentum. Because of transverse velocity, it gains transverse momentum. So, we need a quantum number nr for radial momentum, n phi for transverse momentum. But the condition is nr plus n phi is equal to n. What is nr? Radial quantum number. What is n phi? Transverse quantum number or azimuthal quantum number. The sum of these two quantum numbers, Sommerfeld quantum numbers, is equal to n, which is nothing but the principal quantum number in Bohr's atomic model. The allowed electronic orbits for the main quantum numbers by Bohr-Sommerfeld model. For n is equal to 1, L is equal to 0. Why? Because he has given the new quantum number orbital angular momentum quantum number L. The formula for L is n minus 1. Therefore, for n is equal to 1, there is L is equal to 0. For n is equal to 2, L is equal to 2 minus 1, 1. But the meaning is L is not only 1, the values of L are from 0 to 1. For n is equal to 3, L is equal to 3 minus 1, that is equal to 2. So the values of L are from 0 to 2. Similarly, for n is equal to 4, 0 to 3. For n is equal to 1, L is equal to 0. It is a circular orbit here, which coincides with the Bohr's circular orbit. For n is equal to 2, L is equal to 0 and L is equal to 1. For L is equal to 1, there is a circular orbit which is equivalent to Bohr stationary orbit. For L is equal to 0, it's an elliptical orbit. Totally 2 suborbits are existed in first shell, second shell. Sorry. For n is equal to 3, L is equal to 0, L is equal to 1, L is equal to 2. With L is equal to 2, there is a circular orbit which is equivalent to Bohr stationary orbit. With L is equal to 1 and L is equal to 0, there exists 2 elliptical orbits. Similarly, in n is equal to 4. There is a condition for allowed elliptical orbits. What is that one? N phi by n is equal to b by a. What is n phi? We have already told here. N phi is azimuthal or transverse quantum number. What is n? N is principal quantum number of Bohr atomic model. What are b and a? B is semi-minor axis, A is semi-major axis. The ratio of semi-minor and major axis must be equal to the ratio of azimuthal quantum number and principal quantum number. Then only there is an elliptical orbit existence. Sommerfeld relativistic correction. Electron is revolving in the elliptical orbit with a velocity v. But the velocity of electron is 0.007 c, where c is velocity of light. So it contains velocity comparable with the velocity of light. These particles are called as relativistic particles. So we have to consider variation of mass with velocity. So the maximum velocity exists at nearest to nucleus. Minimum velocity at the farthest point to nucleus. Why it is so happened? We will go to the previous slide. This is the elliptical orbit, this is the nucleus, and this is electron. Why it is moving like this? According to Newton's first law, every body or every particle moves in a straight line with uniform velocity, but it is revolving in the closed orbit shaped in elliptical orbit. To turn this electron from straight line to curved path, there is a need of an external force. That external force is coming from electrostatic force between nucleus and electron. Electrostatic force between nucleus and electron. This is positive nucleus, this is negative electron. So there is electrostatic Coulomb attractive force. So because of that attractive force, it is moving in an elliptical orbit where n is at one of its focus. Okay. So what is the formula for that? We have already studied in your third paper. Coulomb attractive force is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. 1 by 4 pi epsilon naught, it is a constant. What are Q1 Q2? Charge of nucleus and charge of electron. These two are fixed. For an electron revolving in this elliptical orbit, single electron, it is -1. Positive nucleus, it is a fixed one, fixed positive charge. So variable is for this electron r. Here is distance r. If it comes to this position, r may be reduced. When it comes to this position, r may be increased. So when it comes to back here, r is reduced. Denominator value is reduced. Right? So total fraction value is increased. So attractive force is more here, nearest point. Whenever attractive force is more, the velocity of electron is also more. Just vice versa here. So at nearest point, maximum velocity. At farthest point, it contains minimum velocity. So effective mass of electron will be different. Effective mass of electron will be different. Effective mass is m is equal to m naught by root of 1 minus v square by c square. So the curvature of elliptical path is not exactly same at two positions. Right? So the ellipse never be closed or completed. This processing ellipse pattern is called Rosette pattern. This is the Rosette pattern. So there must be a change in energy of electron equation. So he has included this term alpha square in the energy term, Bohr energy term. What is meant by alpha? Alpha is equal to E square by 2 epsilon CH, which is approximately equal to 1 by 370. It is called as fine structure constant. How it was explained? It explained fine structure. We have already studied that electron, its velocity is 0.07 c. It is a relativistic particle. So we should consider the variation of mass. So maximum velocity at nearest point, minimum velocity at farthest point, effective mass will be different. Greater mass near to nucleus, smaller mass near to far to nucleus. So slight variation in energies. Greater energy at greater eccentrical ellipse, smaller energy existed at smaller eccentricity ellipse. So different orbits of smaller variation is n phi in energy for given n. For n is equal to nr plus n phi. For n phi, smaller energy variation will be given. So the fine structure has been explained. I will show you the complete picture here. For n is equal to 2, how many cases may arise? N is equal to 2. We know that n is equal to nr plus n phi. For n is equal to 2, nr is equal to 2, n phi is equal to 0. nr is equal to 1, n phi is equal to 1. nr is equal to 0, n phi is equal to 2. So these three cases may be existed. But n phi is not equal to 0. Why it is so? We'll go to the first slide. Here is phi. N phi is phi related quantum number. If n phi is equal to 0, so this radius is here. No phi here. So electron place is here on the major axis. So if n phi is equal to 0, electron moves like this. So once it comes from through nucleus and then return back through nucleus and come to the point to complete one revolution. Is it possible? Not possible. So n5 is not, n5 is equal to 0 case is not possible. So what may be the next one? n5 is equal to 1, nr is equal to 1. n5 is equal to 2, nr is equal to 0. So in n is equal to 2, with n5 is equal to 1, one suborbital. With n5 is equal to 2, one more suborbital. So in n is equal to 2, there are 2 suborbits. For n is equal to 3, n5 is equal to 1, one orbital, suborbit. With n5 is equal to 2, one more orbit, suborbit. With n5 is equal to 3, one more suborbit. Right? So n is equal to 3 level is split into 3 suborbits. That's why we are finding additional lines in fun structure. This is all about Sommerfeld elliptical orbit.